Hello class, today I'm going to show you how you can do topology optimization to take best advantage of the material we have, have the minimum weight but maximum strengths or minimum stress and so on. Let's start with ANSYS. Today we are going to work on topology optimization of a bracket, and then later you can practice this for other applications or other cases. Okay, let's open static structure. I'm going to keep the default material as a structural still and opening space claim or second cell for geometry. Okay, let's go and have our plane view. Using line, I'm going to draw this bracket. 30 millimeter vertically, 20 millimeter horizontally, and connecting these dots. Let's have round area for corners. Using pool and selecting this ruler, I'm going to add 2 millimeter round corners. 2 millimeter here and 2 millimeter here. Now I want to add 3 holes inside this bracket to have our boundaries over it. 2 millimeter here, 2 millimeter here, and 2 millimeter here. Okay, our bracket is ready. Let's give a dimension to it, and 2 millimeter thickness for that. As you can see, when we are using pool, it generates automatically a surface for the holes, which we don't need it to transfer to our physical analysis. So I right click over it. I can delete or just simply suppress for physics, which means I'm not going to transfer the surface to the physical analysis. Okay, our bracket is ready. Let's go back to the analysis. I'm going to open model. Okay, let's use the default mesh and see if it's good enough or not. Unfortunately, it's not good. We need to have a finer mesh close to the holes. So let's go, and for size function, instead of adaptive, use approximate and curvature. Now let's generate the mesh. Okay, better mesh around the corners, which we expect to have possibly high stress concentration there. Now it's time for, let's see, vertically. Let's have the support. I'm going to add cylindrical support for these two. Apply geometry, radial fix, so no movement at radial direction. Axial fix, no axial, but tangential lets it free, so it can rotate inside these two holes. Now it's time for our force. I'm adding bearing load for this one. Apply geometry. I would like to have components 50 Newton x direction and 100 Newton z direction. Okay, we are done with it. And for solution, let's have stress, equivalent stress. It's enough. Solve the problem. Okay, we have the results. As you can see here, we have highest stress around this top hole and corner here. And the rest, we don't have that much stress concentration. And especially this area, it's totally blue. Let's see if we watch the animation and gradually apply the force. Do we have any stress concentration, for example, at this area? No, not at all. Here we have the minimum stress concentration and always stays blue. So basically we're not taking advantage of the material here, and we can basically remove this material. So let's do this process and removing the material here a little bit around this hole and this hole, and decrease the mass of this bracket. But you need to make a decision how much of the material you want to keep in this bracket. For this case, let's decide keep the 60% of the material and remove 40% based on the topology optimization. I'm closing this one. And if you check analysis system, you are going to see one option for topology optimization. So I'm going to drag it over solution cell and leave it here. So automatically ANSYS is going to connect all the material, geometric, and model to the new optimization system. Okay, let's open setup. Okay. The topology optimization section is added to the tree, and they called it B5 here. As you can see at the graphic area, you can see we have 3 red area for boundaries, and they excluded from the topology optimization regime. But the blue area is the area the topology optimization will be carried out. So system is going to have some change, if it was possible, just over the blue area, not the other areas. Okay, let's check and analyze settings. We have maximum number of iteration, 500 is good enough. The minimum normalized density is this. Convergence, it's okay. Output control, we are happy with it. We're not going to touch this part. Let's go for optimization regime, which we already talked about. It is going to apply for all bodies. Boundary conditions are excluded. Objective, we are going to keep this default. However, the last part is very important, which is response constraint. So we are doing this optimization to optimize what? Mass, volume, displacement, stress, whatever you want. Here we are looking for mass. As we decided, I'm going to keep 60% of this material for here, for the topology optimization. Okay, what else? Let's click solution. Make sure you click and select yes for this case, which is exporting topology STL file, because we want to have the STL file present and saved for us after topology optimization, because we want to evaluate this new design again to make sure everything is okay. So make sure this is you selected yes for this case. Okay, let's solve it. I'm going to open Topology Density Tracker to see how topology optimization is going to apply for our system. Let's see. The iteration started, and you can see the material is gradually removing from the bracket. And as we expected, the blue area, which we hadn't any stress, here is gradually disappearing. Okay, we are done. Let's see animation, how the material is removed from this bracket. As you can see, this area removed very fast, but for the area closer to the higher stress was a bit slower, and we needed more iteration to make sure we removed from the correct area. Okay, we are done with topology optimization. Now everything is ready. We optimize our topology, but we need to evaluate it. So I'm going to right click over solution, over results, and select this case, which is transfer to design validation system. By selecting and clicking this option, ANSYS is going to create another static structural design by topology optimization design as an input for geometry. Let's see. Yes, static structure is created, and you can see the results are connected to our geometry. You need to make sure all the cells have green tick. So for results, I need to update it to have a green tick here. I don't need this, so I'm closing it. I'm just waiting for green tick. Okay, we have green tick here. Now I need to update geometry because I want to make sure the topology optimized geometry is transferred to the third static structural analysis. Okay, let's open geometry. Everything is ready for us. Okay, the system 1 is our original, and the other one is the topology optimized. Let's get rid of the original. Now we have the topology optimized case. If this topology optimized case is acceptable, you can directly open this part and convert and merge all the faces, convert to the one solid, and use it, do the analysis and finish it. But as you can see here, this topology optimization is not manufacturable. There are some rough area which we don't like it for manufacturing, and we need some repairment done over it. So we need to improve this one. So to do that, I'm going to activate a sketch mode, select the surface, and drag whole area to select all the lines around this topology optimized area. Open the repair tab and click over fit curves. In option area, the maximum distance is okay, we are happy with it, but I want to correct tangency. So I'm clicking that one. And now we can complete this task. Okay, now I'm going to select again go to design, copy and paste. At the previous section, when I repaired the curves, I didn't do anything. So because those curves were connected to the 3D case. So what I'm doing, I copied and paste over this area to get rid of this 3D part. And now I have some 2D case. Now I can apply the curve fit, which is going to improve the tangency. Let's zoom it, and as you can see, there's some improvement here. Okay, let's go to the design and get rid of the unnecessary sections. I need to zoom more. So I'm trying to improve our 3D go here, remove this one, this one, this one. Okay, let's zoom to extend the inner one. Let's remove this one, the inner one. Okay, I'm not happy with this one. So I'm going to draw a line here and use let me see if let's delete this one or use pool to smooth this. Also use to smooth this part. Smooth this one. Oh, we have or we could get rid of this part and directly connect this one to this part. Use pool to smooth it. Oh, I don't like this area too, so simply I'm going to remove this part, this part, this part, and just directly connect this to this. Okay, much better. Now I think this is going to be manufacturable. Let's use pool 2mm. Okay. We improve the quality of this. Let's suppress for physics, suppress for physics. So the only thing is left is our bracket, topology optimized bracket. Okay, let's close this one. Okay, it wants to reread the data from upstream. Let's accept this. Just gradually. Okay, now we have our system. See how many surface we have? This one, this one, this one, this one, this one. Sometimes you don't like having this many surfaces. This one is not connected to this one, you know. And this may increase the difficulty we may have for our investigation. So to improve this problem, I'm going to close this, go back to the geometry, and merge some faces. It is better to merge some of those faces to simplify our geometry. Okay, I'm going to zoom here. This one, control, select this one, keep the control this one, go to repair and merge faces and select complete. Now this is one face, much better. This, merge and complete. Let's move here, this one, this one, this one, and this one. We merge this surfaces, this. Now this side. Let's zoom it here. I want to have this as a one surface. Okay, good enough. Now closing it. Let's go to the model, read the data from geometry section, and open the model. The rest would be very straightforward. We are going to investigate a new geometry which is created by topology optimization. Let's wait a little bit to import all the data. Okay, now we have everything here. Okay, let's generate the mesh. Beautiful. Concentration of mesh here. even I can change the relevance from coarse to medium or fine. Let's go with medium. Okay, very good. Now let's assign the boundary condition, the cylinder support. We need to select some surfaces, this one and this one for cylinder. Let's go for bearing load. This one was for bearing. Apply the geometry. The other information is already presented for us. And we are done. Let's solve it. Okay, calculation is finished. Now we can see the material we have. There is some stresses at closest material. We don't have that totally blue area here. We remove that unnecessary material using topology optimization. Let's have animation of the loading. As you can see, the maximum stress is close to here, a little bit here and here, but the maximum stress is at the bear loading position. Okay, now you can do the same for me and send a picture of this page. So you need to take a screen page of your design for the when you find the final stress for the optimized topology optimized bracket. If you want, you can play with other options to see the effect, but I would like to see the final result for your topology optimization. Thank you very much.